Hi everybody. So in this video we continue with chapter 6, trigonometric functions and equations. And now we are going to look at section 6.6, inverse trigonometric functions. And first we're going to define the inverse sine function. So the inverse sine function is defined as y equals arc sine of x, or y is equal to sine to the minus 1 of x. Now be careful because this is not the cosecant function, right? This is arc sine. It has a domain that is restricted from -1 to 1, including -1 and 1, and then also a restricted range from -pi halves to pi halves. It's defined by y equals arc sine of x if and only if x is equal to sine of y. Why are the domain and range restricted? So notice that if we restrict the sine function to a domain from -pi halves to pi halves, we're going to get a range that goes from -1 to 1. And this is something that repeats over and over. We're always going to have values in the range that are going to be between -1 and 1. You can see that arc sine is simply a reflection across the line y equals x of the sine function. And now you have for arc sine a domain that is restricted from -1 to 1 with a restricted range that goes from -pi halves to pi halves. So next we're going to define the inverse cosine and inverse tangent functions. So for the inverse cosine function, we have that it is defined by y equals arc cosine of x, or y is equal to cosine to the minus 1 of x. Now here be careful because this is not equal to, this is not the same as saying 1 over cosine of x, right? This is a wrong equivalency. And then notice again that we have a restricted domain that goes from -1 to 1, including -1 and 1, and a range that goes from 0 to pi, including, of course, 0 and pi. And it is defined by y equals arc cosine of x if and only if x equals cosine of y. So now let's take a look at the graph of cosine for a second. So here we have the graph of cosine, y equals cosine of x, with a domain restricted from 0 to pi. And the range is going to be obviously from -1 to 1. Now this one is decreasing, therefore we start at 1 and end at -1 in this restricted interval, in this restricted domain. So what would the inverse of this look like? A reflection across the line y equals x, of course. So now notice that we have y equals arc cosine of x, and the domain is restricted to -1 to 1, and the range is from 0 to pi. Now let's take a look at the inverse tangent function. So it's defined as y equals arc tangent of x, or y is equal to tangent to the minus 1 of x. Now be careful because this is obviously not cotangent, right? And it has a domain of all real numbers and a range that is restricted from -pi halves to pi halves, defined as y equals arctangent of x if and only if x is equal to tangent of y. So let's take a look at the graph of tangent with this restricted domain. The domain is restricted from -pi halves to pi halves, not including -pi halves and pi halves. Why? Well, because that's where the function becomes undefined, and therefore it has vertical asymptotes. Notice that, interestingly, the range of tangent is all real numbers. That is why if we look at the inverse, which is arctangent, right, the reflection across the line y equals x, notice that it's going to have a domain of all real numbers and a range that is restricted to -pi halves to pi halves, which, by the way, are now horizontal asymptotes. So now let's do example 6.28, and it says, without using your GDC, find the exact value of each expression. Part A, arc sine of minus square root of 3 over 2. So how do we approach this? Now, first of all, remember the concept that if you have that y is equal to arc sine of x, then this implies that sine of y is equal to x. So in other words, sine of y is equal to minus square root of 3 over 2. So all we have to do here is solve for y. Now, if you're not sure which angle measurement would give you negative square root of 3 over 2 for the sine of y, then use your reference triangles, right? The special right triangles. Now, wherever you see square root of 3, you know it's got to be the 30, 60. So here we would have 30 degrees, or pi over 6. Then here let's have 60 degrees, which would be pi over 3. And with this, we know that the smallest leg is going to be opposite the 30-degree angle, or pi over 6. So this is going to be 1. The hypotenuse is going to be 2. And then opposite pi thirds, you're going to have square root of 3. So notice that sine of pi thirds is equal to square root of 3 over 2. Now this is positive though. So that means that this is not the solution yet, right? We can find the solution using the unit circle. Now, the range of arc sine is restricted to minus pi halves to pi halves. Therefore, our solution has to lay somewhere in the first, right? In the first or the fourth quadrant. But notice that this solution is negative. So that means that our solution would be here, right? It would have to be this angle here. And this angle is minus pi thirds, because this coordinate here, remember that this coordinate would be positive for cosine, which would be the x coordinate, right? So cosine of negative pi thirds would be 1/2. We can see it here in the reference triangle, right? Adjacent over hypotenuse, 1/2. And then for sine, or the y coordinate, it would be minus square root of 3 over 2. So that means that we have a solution, right? That means that y here is equal to negative pi thirds. Therefore, arc sine of minus square root of 3 over 2 is going to be negative pi thirds. Now for B, they want us to find the arc cosine of 1. So that means that cosine of y is equal to 1. So where does cosine equal 1? Well, right here, right? This point, because this is 1, 0. Now, that means we have a solution. That means that arc cosine of 1 is simply going to be equal to 0 radians. Now, C, arc tangent of square root of 3. So where does tangent of y equal to square root of 3? So notice that this is the same as square root of 3 over 1, right? And tangent is opposite over adjacent. So that means that this is equal to pi thirds. And we can see that over here. This angle here would be pi thirds, and this coordinate, 1/2, comma, square root of 3 over 2, because now sine would be positive there. So we have the solution, right? Pi thirds. Now for D, they ask us to solve arc sine of 3/2. So that means that sine of y is equal to 3/2. But notice that 3/2 is the same as 1.5, which is greater than 1. Therefore, this has no solution because sine has a range between -1 and 1. So now let's talk about compositions of trigonometric and inverse trigonometric functions. So from chapter 1, we learned the following properties for a pair of inverse functions. If you plug the inverse into f of x, you're going to get x for all x in the domain of the inverse. And if you plug in f of x into its inverse, then you're going to get also x for all x in the domain of f. And these properties hold true as well for inverse sine inverse cosine, and inverse tangent. So what are these properties? If a value alpha, and notice that it's a value, not an angle, if a value alpha is between -1 and 1, then the sine of the arcsine of alpha is just going to be alpha. In other words, these would cancel each other out. Now, the condition here, though, is that alpha has to be in the domain of arcsine and in the range of sine, right? Otherwise, it doesn't have any solution, obviously. Now, the angle beta would have to be in the range of arcsine and in the domain of sine, the restricted domain, which is between negative pi halves and pi halves, including negative pi halves and pi halves. And then if this condition is true, we would have that the arcsine of the sine of beta, they cancel out and you get beta. Notice that it's very similar for the other two inverse trigonometric functions. So let's continue with example 6.29, and it says, find the exact values, if possible, for each expression. Letter A, inverse cosine of the cosine of 4 pi thirds. So here you might be tempted to just simply go, this equals 4 pi thirds. But this solution would be incorrect. Now, why is that? Because remember that we have a range for inverse cosine that is from 0 to pi. And 4 pi thirds is obviously not within this range, right? Notice that this is pi thirds right here. This here would be 2 pi thirds, 3 pi thirds, which is pi, and then 4 pi thirds would be here. So this is out of the range. Now, does that mean that this has not a solution? No, it does have a solution. What we have to find is the equivalent for cosine at 4 pi thirds, right? Cosine of 4 pi thirds is equivalent to cosine of what? Now, we know that cosine is negative in the second quadrant, right? Remember that here cosine is negative and sine is positive. And then also in the third quadrant, we have that cosine is negative and sine is negative. So that means that the mirror cosine for 4 pi thirds would be 2 pi thirds. So we have that cosine of 4 pi thirds is equal to cosine of 2 pi thirds. So this would allow a solution for this, right? So that means that the solution for cosine or inverse cosine of cosine of 4 pi thirds is going to be 2 pi thirds. Now, this was a solution for A. For B, we have tangent of the arctangent of -7. So before we say that this is equal to -7, let's think about this for a minute. So -7, is that within the domain of arctangent? Yes, right? Because remember that the domain of arctangent is all real numbers. And likewise, or consequently, if you may, it is within the range of tangent. So that means that tangent of arctangent of -7 is going to be -7. Now for C, we have sine of the arcsine of square root of 3. So again, here the question is square root of 3 within the domain of arcsine or within the range of sine? So whatever is easier for you. Now remember that the range of sine is going to be between -1, right, for sine, and 1. So is square root of 3 within that range? Well, no, right? Because square root of 3 is obviously greater than 1. Therefore, that means that this is undefined, or it has no solution. So we continue with example 6.30, and it says, given that C is equal to arctangent of 3 plus arcsine of 5/13, find the exact value of cosine of C. Okay, so with these problems, what we need to do is simplify them a bit. So notice that I can say, let A equal arctan of 3. And we can say let B equal arcsine of 5 over 13. Then we can say that C is equal to A plus B. And then if we apply cosine to both sides of this equality, we get that cosine of C is equal to cosine of A plus B. But from identities, we know that this is equal to cosine of A times cosine of B minus sine of A times sine of B. So that means that we need these values for cosine of A, cosine of B, sine of A, and sine of B. What we have is this here, right? We know that A is equal to arctangent of 3. So that means that tangent of A is equal to 3. Now this allows us to find the other trigonometric ratios, right? Because we can use the Cartesian plane, and notice that if this angle here is A, tangent is opposite over adjacent. So this has to be 3 and this has to be 1. Therefore, this has to be square root of 10. So that means that sine of A is going to be equal to 3 over square root of 10, which is the same as 3 times the square root of 10 over 10. So cosine of A is going to equal 1 over square root of 10, which is square root of 10 over 10. So we have sine of A and we have cosine of A. Now we need to find sine of B, but we have this information, right? Notice that here, from this, we can say that sine of B is equal to 5 over 13. But then again, using the Cartesian plane as a reference, if this is angle B right here, then sine is opposite over hypotenuse, right? So this would be 5, this would be 13. And if we do Pythagoras, this is going to be 12. So notice that that means that the cosine of B is going to equal 12 over 13. So now all we have to do is substitute in here in order to solve for the cosine of C. So cosine of C is going to equal cosine of A, which is square root of 10 over 10, times cosine of B, which is 12 over 13, minus sine of A, which we said is 3 square root of 10 over 10, and sine of B, which is 5 over 13. Now, if you do the math here, you're going to get that this is going to be negative 3 square root of 10 over 130. In other words, we have the solution, right? Because that means that cosine of C is equal to this, what we just found, minus 3 square root of 10 over 130. So now we're going to do example 6.32, which will be the last one on this video. And it says, a painting that is 125 centimeters from top to bottom, so that's the width of the painting, is hanging on a wall of a gallery such that its base is 250 centimeters from the floor. Pablo is standing X centimeters from the wall on which the painting is hung. Pablo's eyes are 170 centimeters from the floor, and from where he stands, the painting subtends an angle of alpha degrees. Part A, write a function for alpha in terms of x. So this is what the sketch should look like. Now notice that we have all the information here. First of all, we have the height to Pablo's eyes, which is 170 centimeters. We have the distance from Pablo's eyes to the wall, which is x. We have that the painting is 125 centimeters wide. We have that the base of the painting is 250 centimeters from the floor, and that implies that from Pablo's eyes to the base of the painting, there is 80 centimeters. And then notice that we have named the angle alpha, which is right here, the angle at which his eyes subtend, looking from the base of the painting to the top. And notice that we have named this other angle here beta, which is the angle that would be from the horizontal that is represented by his eyes up to the base of the painting. And then both angles together would be theta. So how can we write a function for alpha in terms of x? Now, the first thing we need to do is find the relationship between alpha and the other two angles. So notice that we have that alpha, so for part A, we have that alpha is equal to theta minus beta. So if we want a function for alpha, we can say tangent of alpha, right? Because tangent of alpha, notice that this implies tangent of alpha is equal to tangent of theta minus beta. So this implies that we can use one of the identities, right? So that would mean that tangent of alpha is equal to tangent of theta minus tangent of beta divided by 1 plus tangent of theta times tangent of beta. So that means that we need to use the values for tangent of theta and tangent of beta. But notice that we can see that from the drawing because tangent of beta is easy to see. Tangent of beta, 80 over x. And then for tangent of theta, it's going to be 125 plus 80, and that's going to be 205, so 205 over x. So tangent of alpha is equal to 205 over x minus 80 over x, and all this divided by 1 plus 205 over x times 80 over x. Okay, so if you do the math here, you're going to get that this is equal to 125x over x squared plus 16,400. But we're not done because they want a function for alpha, and this is a function for tangent of alpha. But that's easy to do because notice that alpha is simply going to be the inverse tangent of this expression, right? So the inverse tangent of 125x over x squared plus 16,400. Okay, so for part B, it says find alpha accurate to 3 significant figures for the following values of x. Part 1, x equals 75 centimeters. So that just means plugging 75 and substituting for x, right? And if you do that, you're going to get that for this case, alpha is going to equal 23.06 degrees. If you plug in x equal to 125, you're going to get that alpha is equal to 26.01 degrees. And for the last one, if you plug in 175 for x, you're going to get that alpha is equal to 24.95 degrees. For part C, it says, using a GDC, find to the nearest centimeter how far Pablo should stand from the wall so that the subtended angle alpha is a maximum. So what we need to do is plug in the function y equals inverse tangent, so inverse tangent of 125x, so 125x, and this divided by x squared, so x squared plus 16,400, so plus 16,400, and then here we have to close one parenthesis and then another one. But before graphing this, we have to be sure of the window size. Now the window is going to depend on the domain and range. So notice that for the domain, we're plugging in values ranging from 75, notice over here, 75 to 175. And notice that the angles that we get, first we get that alpha is 23 and some degrees, then 26 and some degrees, then 24 in some degrees. So it looks like the maximum should be here between these numbers, right? Between 125 and 175. But what I need here is to know the domain and range. So 200 is a safe number for the maximum for the domain. So that's what we're going to use, 200. And then for the range, since we're doing degrees, let's say from 0 to 30. So once you're certain about the window, it's time to hit graph. And there it goes. Notice that it's going up, 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 up. It seems to have reached the maximum. It sort of flattens out and it starts coming back down. So what we want to do is use a function, which is second key calculate, and number 4 maximum. So number 4 maximum is going to say left bound, and you want to be sure that you are to the left of that maximum. So that's far left enough, hit enter. And then right bound, you want to be sure that you are to the right of that maximum. So let's move to the right all the way until it starts moving down. I think that's good enough. Hit enter and then guess, and boom, there it is. So that's the maximum of that inverse tangent function. So that means that we have an answer for C, because we can say that the x distance that Pablo should stand from the wall would be, and it says to the nearest centimeter, so x would have to be actually 128 centimeters, and that would give him the maximum angle subtended, which is 26.01 degrees. Notice that this is very close to what we had here at 125 as well.